Hello everyone, my name is Hossein, and in the second part of this video series on the ReQue, I'm going to explain how to install the ReQue toolkit. Uh, ReQue is available online on GitHub at this address, as you can see here, for the master branch. So the first is that there's a README here that explain all the folder structure and the prerequisite to install the ReQue and the installation process. So you can read them carefully to install the ReQue, but now I'm going to explain how to install the ReQue. So for the installation of the ReQue, you have to simply first clone the code line from the GitHub by this command. So it basically downloads the code base to your PC or computing environment, and then it creates the folder ReQue. So you have to simply go to that. If you see the content, there are some folder directories or some files. Now I'm going to explain a little bit about the folder structure of the code base. So in the README, we already put more information about that. The first main subfolder is the QE, as you can see here, which includes all the source files for expansion methods, which are all in the expander subfolder. Abstract expander is expander based on the stemmer, expander based on the embedding method, etc. Also, all the stemmer based expanders are in this stemmer subfolder. There are two other folders: the common folder, which is the which includes the common functions or util functions for the other expanders, and the evaluation, which is basically a code that runs and extract some statistics based on the performance of the expanders on different query sets. But the main file in this folder, the query expander folder, is the main.py, which is the running or the core engine of the ReQue that has four main functions: generate, search or information retrieval, evaluation, and then database generation. The second main folder is the QS or query suggestion method or query suggesters. In this step, actually, we use the code base from the cur. As you can see, it's available online in order to benchmark our final data sets. So basically, given a query set, for each query, we expand the query and keep those queries that increase those versions of the query that increase the information retrieval, the performance of the information retrieval. So the final data set includes a query and the expanded version of the query that increase the performance, which we call them refined query. So then we applied some supervised query refinement methods, such as sequence to sequence with attention, and also this one, the context-aware query suggestion method, in order to show that, in order to produce some benchmark results for the purpose of reproducibility on the supervised query suggestion methods on our final query refinement data sets. So let's back to the other folders. There are three main folders, such as pre and answering and DS. For the pre, initially when you clone the code line, these folders are empty because the files inside these folders are huge, and we couldn't push them to the GitHub. So you have to download these files. The first folder is pre, which includes all the pre-trained embedding models such as GloVe or FastText or Anchor-based embedding files. So there are some links in the README that you can go there and download these pre-trained model. In the Answerini folder, as I said, we used Answerini for information retrieval methods. Also for the evaluation, we use the track eval. So these two libraries are must be available at the Answerini folder. So you can go to these links and download them and build them. Also, if you already have them in your system, ReQue, you can just adjust the path to these libraries in the ReQue in order to use them in the steps of the ReQue. And the last folder in this set is the dataset or DS, which includes the query sets for each corpus. For instance, for the corpus of robust, we have the query set for the robust. Also, it includes the index on the corpus of the robust, which is produced by the Answerini library. So we use the Answerini library to index the corpuses. And the index folder gonna be in the DS folder for each corpus, as you can see in this folder hierarchy. And the last set of folders are the target folders that actually it includes the output of the running from the ReQue. So after the run of the ReQue on a query set finishes, it produces data sets. And these data sets, as I said, includes each query and the versions of the query that increase the performance of the retrieval method. We already run the platform for the ClueWeb, Gov2, and Robust, and these data sets are already available on the GitHub. There are two other subfolders in the DS, which is related to the query suggestion output. As I said, the result of the benchmark using the supervised query refinement methods on our own data set, on our own produced data sets. And also the eval subdirectory, which is about the statistics on the expander method. For instance, what expanders actually performed, well on all corpuses, or what expanders could yield to the, better performance for which corpuses. So some stats on the expander methods are in this file, in this sub directory. So these are just explanation of the folder structure in the ReQue code line. And as I said, some folders are empty and you have to populate these folders by, downloading the files or libraries. And the others are empty. And after you run the ReQue toolkit, it's going to be populated by the result of the expander methods and the result of the framework. In order to run the ReQue, there are some prerequisite libraries, Python libraries, and as I said, the pre-trained model that you can download from these, and also the query corpuses and the query sets that are available in these links. So let's, after the second step after, you have the code line is, let's go to the installation, is to build a Conda environment, which is because the ReQue is based on the Python language. So you have to build a Conda environment, including all the prerequisite Python libraries. So we already add the environment YML file in order to make it easy for you to install all the Python prerequisite libraries. So basically you have to just simply inside the ReQue code line, there is a file called environment YAML file, which is for creating a new Conda environment. So you have to simply run this command, conda env create environment.yaml, which creates a new environment, Conda environment called ReQue at your system. Oh, sorry, I did a conda. So as you can see here, after creating the after running the create environment, you can see this message that it says basically it creates this environment successfully. You might see some commands that it says it's already available in the environment. So, and after that, you have to activate the newly, created environment, such as by using this command, activate. And the name of the environment created for you is called ReQue. So, and then you go to the ReQue environment. So now it is ready to run the environment as far as the Python language actually concerns. The next step after creating the new Conda environment, which includes all the prerequisite Python libraries, is installing the answer-ini and putting the library and also the track eval in the answer-ini folder. You can go to this link and then download the answer-ini and follow the step to build the answer-ini library. Also for the track eval, the same. You can go to the track eval library. Available in this, I believe it's here. It's already included in the answer-ini library, but you can go to this link, track eval, to just download the track eval and then build it. If you already installed that in these two libraries in your system, you can simply just specify the path of the answer-ini library and the track eval. One thing is that after you install the answer-ini and the track eval, the next step is, given a corpus, you have to index your corpus. So using the answer-ini library by these commands, you can simply index your corpus. We already did that for the robust, Gov2, and ClueWeb, two versions of the ClueWeb, and you have to do that, and then you're ready to run the environment ReQue toolkit. So after creating the new environment in Conda, which includes all the prerequisite Python library, as you can see here, and activating the environment, as I said, you are ready to run the ReQue. But as there are some prerequisites for the pre-trained embedding files that you have to download them and then put it in the pre folder. Also, for running the ReQue on a corpus, you have to download the corpus and the query set for that corpus, as well as the relevance judgment for that. Also, you have to apply answer-ini to index the corpus. So basically, all these steps actually already explained in the README. For now, I already download the query set for the robust data set, and I did index the, also download the robust data set, and I did index the robust using the answer-ini. So, and then I put it the query set and the relevance judgment in the DS. As you can see in the DS, for each corpus we have a folder. So I create for the robust, actually I prepared the relevance judgment, which is a QRL for that, and also the query set, the topics of the included query set for the robust. Also, you have to index the robust, but I already have the index of the ClueWeb, robust, and etc. in another path. As I said, if you already have answer-ini and the index or the corpus in already available in your system in other paths, you can simply adjust the path to those places in your computer to run the ReQue. So let me show you that I already has the corpuses in this path of my system. So as you can see here, I already have indexes for the ClueWeb 09, ClueWeb 12, Gov2, and robust. Also, I already installed the answer any library. As you can see here, the target, this is the source for answer any, and this is the when you build the answer any, this the target includes the built version of the answer any library. The eval library is the for the trick eval library. So in this path, I already have these two libraries and the indexes for the corpuses. So let's back to our environment that we cloned the ReQue. So now we are ready to run the platform for at least for the robust query set. So in order to run, you can in the README file here there are some sample running commands. So to run the ReQue, you have to go to the QE or query expansion folder. Here the main file as the entry point for the for the workflow is the main.py, which includes the function for generate, retrieving the document, evaluate the retrieved document, and then build the final dataset for the refined queries. So as you can see here, I'm going to run the workflow or the ReQue for the dataset robust. And the path to the answer is not this anymore. This is the default path, but I'm going to change it based on the path I installed the answer on my computer. Also the path to the index on the robust data set, where I'm going to output the result and the final data, refined queries. And in the retrieval step, what retrieval method I'm going to use here, I set BM25, and in the evaluation step, what metrics I'm going to use in order to find those expanded version of the query that increase the performance. So in this case, I'm going to find those expanded versions that increase the map. So let's run this command. But as I said, my answer is already installed in, and the index of the robust is in these different paths, in these paths, data. Also, the corpus is robust, and the path to the library of answer library is here. So right now we are ready to run the workflow. But before entering the command, I have to explain that this works after running the main.py. It runs all the available expanders on the given query set here, the robust query set. The list of available expanders are in this, just below the class diagram for the expander methods or expanders. In the common subfolder in the expander factory.py, you can see all the available expanders in the ReQue platform so far. So basically, it just create an instance of each expander and then put it in an array and run it through the workflow. So this is one thing that you have to pay attention on that. So basically, these are the first step. As you can see, these boxes for the expanders. And for the sake of sometimes you need only to run 2 or 3 expander method. So you can simply go here and then just comment all other irrelevant expanders and then just keep the one that you want to run in the workflow. This is one thing. Another thing is that in the main.py, the main, let's go to the query expander. In the main.py, which is the core engine of the ReQue for running the expander methods, the entry point here, this is the main function, so it runs this function run. There are 4 operations for each step of the ReQue platform. Generate, which generates the expansion, which expanded the given query based on different expanders. Search, which tries to retrieve the relevant document given the queries. Evaluate based on the given evaluation metric, and then build the final data set. Sometimes you only need to run the generate step only just to see what are the expanded versions. Sometimes you need just to do the search. So basically this pipeline, the ReQue toolkit, is implemented based on a pipeline so that you can enable or disable some step of the pipeline. So for the sake of time, I just wanted to run 1 or 2 expander methods, and just for the generate step of the toolkit, just to see what's the result of the first step in the pipeline given 2 expander methods. So as I said, I went to the main.py, Python code, and then in the entry point, before running the entire ReQue toolkit, I just said that let's just run the ReQue for generative step without the other 3 phases, just to see how the generative step actually generates the expanded version of each query in a query set. Also, for the sake of time, I went to the query expander factory in the comment. So basically, in the comment folder in the expander factory, oh yes, the expander factory, Python file. As you can see, I comment all the other expanders just to avoid running them or adding them into the expanders array. The only 2 expanders are the stem based on the trunk 5 and the stem based on the Lovin's stemmer. So I just left these 2 on comment, and all other expanders are comment. Also here, in this section actually dedicated to the pseudo relevance feedback expander, so I comment all of these expanders too. So and then I save them. So basically, I'm going to run the ReQue only for 2 expanders based on the stemming of the terms in the query, and just for the generate phase. So let's run it. So this was the command we were supposed to run. So running the main.py by Python interpreter based on the path of the answer in my system. Also for the corpus robust 04, and the index on this corpus is available here in my system. The output gonna be in this folder, the data set for the query expanders, for the dataset robust 4, and I'm going to run the ReQue for the BM25 in the retrieval and the evaluation part map. As I said, for this run, I just want to run the generate, so we don't run the retrieval step and also the evaluation step. So these 2 doesn't actually matter here in this run. So let's run it. So because I put an ampersand in the end, it goes to the background. Oh, it says, so let's see. There's an error. It says that it cannot find main.py. Oh, yes, main.py is in the QE in here. So let's run it. So as you can see, one job's in the background is running. So now you see the result of the log output of the toolkit, the ReQue toolkit. You see that, for instance, given this query, the stemmer trunk 5 makes it this. For this query, it makes it this. So for the query number 671, it makes this query to this based on this expander method. So all the logs, these are for the logs for this trunk 5. So for the Lovins stemmer, these are the log for the way it expanded the given query. After that, it creates some output files and to store these expanded version for the next step, which is the retrieval step. So after a while, when these two, stemmers are very quick. So just stemming the terms inside the query. So you can go through the output folder, which is in the root folder of the ReQue in the DS for the query expander results. We run it for the robust. So let's see what's going to be in the robust. So you see here that there are three files. One of is the abstract query expansion, which basically just given a query, it outputs the query. So this is exactly the same as the query set for the robust. But the other two include the expanded version of each query in the robust query set. So let's have a look at the stem for the Lovins. So as you can see here, the file structure for the output based for the expander method is exactly the same as the query set, but the only difference is the query itself. So for instance, for the query 301, this is the expanded query based on the stemming of the Lovins, because this is in the Lovins file. For other, queries the same. Let's see, look at the other expanded version. So for the trunk 5, again, file structure is the same as the given query set, but the only difference is the query. So this is the expanded version of the queries 301 and etc. So now let's run the ReQue given these two expanders, the trunk 5 and the Lovins stemmers for the whole steps. So not only for the generate, for the search, evaluate, and bid. Let's see whether stemming actually increase the performance of a retrieval method or no, and if it increases the performance, how much, given the performance metric, for instance, map. So I already uncomment this line in my running my main.py. So now it includes all the 4 steps, and let's run it. So again, if you see the main.py, oh sorry, oh it's in the QE folder, the main.py. So let's see main.py just to show you that. So again, as you can see here in this line, I just let the ReQue to run for all the operation.